Welcome back to Data Science on the Fly. In today's tutorial, we are going to talk about feature engineering. So we'll continue using the fraud data set, and today the focus is again feature engineering. So a little bit of an intro. When I first heard about feature engineering, I thought it was a really fancy term and I did not understand what it meant. But actually, feature engineering can be anything from very simple process to more complex, more involved. We're going to start today with really just covering a simple example, and you'll see that as you gain mastery over Python and specifically pandas as the library, as an important library in data science, you will become it'll become a lot more natural and easy for you to engineer features. And you may find that as you're working on your data science projects, you do engineer features often. So let's get started. It's the same way we get started every time for practice, just to make it become second nature to you. So bring in library. For today, we really just need pandas. So I'm going to import pandas as PD. And then let me run that. And then I'm going to read in the data set. So to read in the data set, I am going to create this variable. We've created it before, fraud_df equals, go into pandas, get me the read underscore CSV method, and it takes an argument. And the argument is the local file path, whatever your file path is for the CSV file. For me, it's datasets fraud data.csv. And even if you didn't go to Kaggle and download this, that's fine. You can just watch along and that will be sufficient. Okay, so we have that. This one always takes a little bit longer than expected to run for me. Okay, so let's just quickly use the .head method to ensure, yep, looks like the rows are there. So this is telling me that this fraud_df variable that I've declared actually has a data frame inside of it. Okay, and in other tutorials, we have discussed the other checks that you as the data scientist / data analyst should run when you are dealing with a new data frame, or when you're, acclimating yourself to whatever SQL tables you're bringing in to look at. But for our purposes here, we're going to zoom past that and just kind of go into the feature engineering part. So to do that, let's start off with, well, I want to see what columns there are in this fraud_df data frame. So I'm going to do list and then parentheses fraud_df dot columns. Okay, great. I could have just done this fraud_df dot columns, but that gets me back some brackets I don't need, some words I don't need. So the list, just passing that as an argument to the list method, just makes it cleaner, gets me back this clean list of only the column names. Okay, so I don't have a data dictionary for this. I don't know what each of these terms means, but looks like there is an is fraud column and an is flagged fraud column. And then there are some other columns here, which to me, my initial impression of them is, oh, they look like predictors. And then this looks like the outcome variable trying to get predicted. And this looks like maybe somebody built a machine learning model using these predictors, and these are their results. And maybe one thing that we could do at some point is compare, is a row actually a fraud transaction versus did the machine learning model flag it as a fraud transaction, to see how well the model is performing. But let's take a step back and focus on feature engineering, and we'll get there. So next step here is I want to see what the data types are for each of these columns. So looks like, here I have some strings. I've got, like, this looks like string data type because it's a mix of characters and digits. Maybe this is float because it's numerical, but it has decimal points. String for type, right? It looks like words. And then I also see here is fraud and is flagged fraud. Those only have zeros and ones, it seems like to me. But before I can make that conclusion, let me just actually check. So fraud underscore df dot is fraud gives me back just that column. These are just indices over here. But this is all the column, all the row values for the is fraud column. And you know what? I want to see what the unique values are. What are all the unique values in this column? Yeah, 0 and 1. So this is looking like a Boolean that's only taking two values, 0 and 1. And the common notation is 0 means false and 1 means true. Okay, let's look at is flagged fraud. So same as the above, start with a data frame, but only I want the is flagged fraud column, dot unique. Yep, 0 and 1, Boolean. Okay. So going back to feature engineering, the feature that I want to engineer doesn't yet exist in this data frame. It's not part of this columns list. But I was saying that it would be interesting to see how often this flagger is matching whether or not a transaction is actually a fraud. So it might be interesting to make a feature engineer a feature that looks at the correctness of that. So I'll get started with that. And now this may be a bit more complex for some of you, and that's fine. Just follow along, and slowly, it just becomes really simple and easy. It's like learning a new language. So to create this new feature, creating a new feature from existing features, that is the same as feature engineering. All right, so to create it, I go fraud underscore df, because that's the data frame, and then in brackets, I put the name of my new feature. You can choose a different name that I'm going to choose, but just make it reflective of the actual point of the column. Like, why does the column exist? So I'm going to call it correct underscore flag, because I am trying to see how often the flag matches whether or not it's a fraud. How often are these two values the same? And so in order for me to get that information, I'm going to go to fraud underscore df, and then I'm going to say, give me back the is fraud column, and check if it's equal to, remember that the double equals here checks for equivalence. Check if it's equal to fraud underscore df dot is flagged fraud. Do that. Okay. So we run this, okay? And now let me check out my original data frame. Look, I have this new column here, correct flag right here, and it's a Boolean. And it's true whenever is fraud, this row value matches the is flagged fraud value, and it's false when they don't match. And so there is really no real interpretable difference between the zeros and ones here and the trues and falses here. They're interchangeable, and as long as you know what true is meaning and what false is meaning. So in this case, true means that if both of these are 0, true. If both of these are 1s, true. False means if one is 0 and the other one is 1, that's a false, or vice versa. The values aren't matching, then it's a false. But I could take these and I could convert them into 0s and 1s. So let me see what happens if I do that. So to do that, I would say I want the correct flag column, but I want it as type int, and I get these 1s and 0s. So I'm actually going to do that up here. I'm going to say, let me just do that here. So I'm going to say, okay, everything's the same, but now I want as type int. Okay, great. Now, let me just run fraud df again. If I look over here, now look, where there were trues, there are ones, and where there were falses, there are zeros. So false is when these two values differ, and it's represented as a 0 in this column. 1 is where these two values are the same, and it's represented as a 1. So now we have engineered this correct underscore flag column that helps us understand how well whatever machine learning model, whatever measurement tool predicted this is flagged fraud, how well that's doing in comparison to actually is this transaction a fraud or not, the truth, reality. And that's a really big focus in machine learning, accuracy and tests for accuracy. So this was a short introduction into feature engineering. This is an engineered feature. It did not previously exist in the data set and in the data frame, but we created it from existing features, and now it exists in our data frame because we've put it in there. Okay, until next time, talk later.